So hello everyone, welcome back to the channel. So today we are going to solve the problem Shy Geek. It's a medium problem. So Geek went to buy some chocolates from nearby shops. With K coin in his pocket, he found a shop contained N chocolates which are arranged in sorted increasing order of their prices. Now Geek wants to taste costlier chocolate, so he decided that he will buy the costliest chocolate. Till there exists at least one type of chocolate he can afford. So there is infinite supply of chocolates in the shop. So also Geek is a shy person. So he will inquire about the price of chocolate at most 50 times from the shopkeeper. Now, your task is to find the number of chocolates he had enjoyed. So this is a question. So let's focus on the question. Okay. So let us consider a test case like n is equals to 4 and k is equals to 9. Okay. And we are given the array 1, 2, 3, and 4. Okay. Now, I have number of coins as 9. Now, this chocolate is costliest. Now, they are asking for two things. First, we need to have a costliest chocolate, no matter how many chocolates. Yes, we don't want many chocolates. We want to get as costliest chocolate as we can. Secondly, we are given the sorted array. Okay. So now let's say we are 1, 2, 3, 4. Now, this is the costliest chocolate, 4 price, 3 price. So costliest chocolate is 4 price. Now, from the coins 9, 9 minus 4 is equals to 5. So I can buy this chocolate. So let's buy this chocolate. Now, now I have 5 coins. I can again buy this chocolate because I can afford it. So 5 minus 4 is equals to 1. So let's buy again. Now we are left with 1 coin. So can I buy it again? No. Can I buy this? No. Can I buy this? No. Can I buy this? Yes. Okay. So let's buy this also. It will become 0. So this is a question. We have to count the number of costliest chocolate as we can. Okay. So now one thing that you can ask, like, let's say 1, 2, 3, 4, and we have k is equals to, let's say, 10. Okay. So I will buy 4. I will buy 4. Then I will buy 3. Okay. I can buy 2 ones. I can buy 4. I can buy 4. I can buy 2 ones, but they will not be costliest. We will not buy it. We will buy 2. As I said, don't not matter how many chocolates. I get 4 chocolate, but no, I will get 3 chocolate, but they should be costliest. Okay. So let's understand the brute force approach that we can apply. Don't focus on 50 operations are required. Let's focus that we can apply as many operations as we can. So linear time approaches, let's say this is a big of an approach. Like how can we do this? What we do, like we have 55 coins. So we are given 20 price chocolate. So we will buy, since it is given in the sorted array. So obviously this chocolate price will be highest. So I will try to buy it. If I am able to afford it, yes, I am able to afford it. So from the 55, I will buy this and my price will become 35, which I'm left with. And I have bought 20 price chocolate. Now with 35, can I buy 20 chocolate again? Yes, let's buy it. Now we have again 20 chocolate, 20 price chocolate. So we will buy it. Now we are given to 15. Can I buy it again? No. Can I buy it with this price? No. Can I buy it with this price? Yes, I can buy it. So this is the costliest. We will not buy this. We will buy costliest chocolate. So 50 minus 10 is equals to 5. So let's buy this 10 chocolate, 10 price chocolate, and we are left with 5 coins. Now with 5 coins, can I buy this? Can I buy this? No, no, no. Can I buy this? Yes. So I will again buy this. We will be left with 0. Now we have bought 5 price chocolate. So these are the number of chocolate. That is, answer is equal to 4. So this is the brute force approach. We will not check it because we are left with 0 coins, obviously. So this is the brute force approach. Now we are given, so we want to observe two things. So first we are given sorted array. Okay. Secondly, we are given that we have to apply only 50 operations. Okay. So obviously it will take big of an operation. So it will go up till 10 to the power 5 operation. If the array size is 10 to the power 5. We want to do in 50 operation. Also, we are given sorted array. What hint we can get from this? We can get like, we want to apply binary search. Okay. Now, how can we apply binary search? So let's come to the binary search approach. Okay. So within the brute force approach, what I have understood that when I have taken 20, so after that, I will come to 10. That means whenever I've taken 20 coins, so let's say I have 55 minus 20 is equals to 35. Now 35 minus 20 is equals to 15. So now I'm left with 15 coin. So I will go back. So now I will come here. Now I will take 15 minus 10 is equals to 5. Now I will go back here again. Now I will come to 5. I will check. Now 5 will be affordable. So I will take 5 minus 5 is equals to 0. Now what we can see, what we can observe from here is that whenever I was taken, I have taken 20. So whenever I go to 10 again, now I go to 5 again. So I can see that whenever I have taken 10, so should I need to check this 20 again? No. Why? Because this 20 have given that much. That is affordable. That means 55 minus 20, 35. 35 minus 20 is equals to 15. Now 15 cannot be more affordable by 20, obviously. So I will go back. That means my range is reduced. So from this range, let's say this is the range. So I've reduced to this range. And whenever I've taken 5, so should I check 6, 8, 9, 10, 16, 20 again? No, because 5 is only affordable by or here. But I want maximum costly, so I will take this here itself. Now, this is the range that is affordable. So what I can see that I can make the binary search within some range. So let's say, so second thing that we have to understand, like, let's say we are given 55 coins. Okay. Now I want to buy the costliest chocolate. So this is the price of the chocolate, that is 20. Now, how many chocolates I can buy from this? 55 by 20. How? That is 55 minus 20 is equals to 35. 35 minus 20 is equals to 15. So this 20, 20. So I will say 55 by 20 is equals to 2. So I can buy 2 chocolates. Now, how many amount I will left? 15. This can be calculated by 55 modulo 20. That is 15. So we can say for counting the number of chocolates, currently we can say count is equals to k by price of the chocolate, and for the remaining price I will say k modulo price of I. So this thing is basic and this thing should be clear. Now let's come to binary search approach. Now what is a binary search approach? So as I said that I will reduce the range. Let's say there is 20. Okay, so my range is start here and end is here. So I will find mid here obviously. 0 plus 9 by 2, mid is here. So I will say, okay, 6 is affordable by 55. Okay. So, okay, if 6 is affordable, let's mark this as answer that mid can be 6 only. This 6 can be the answer. We will mark obviously index. This 6 can be the answer. So mid is 4. And I will say, let's say this mid is 4. So I will take that. Let's go mid plus 1. Start will go to mid plus 1 because if this smaller range can be possible, maybe bigger range can also be possible. So because they are given in sorted order, so we can assure that ahead only greater elements are present. So when I take mid 5 plus 9 by 2, it will be mid here. Now I will say, let's say 10. Can 10 be affordable by here? 55. Yes. Okay. So I will say 10 chocolate can be bought. 10 price chocolate can be bought. So let's mark mid as 10. We can mark index. Let's mark the elements only. Okay. Now, since this can be affordable, so maybe greater can be affordable. So left shift start is equals to mid plus 1. Now I will check here whether 8 plus 9 by 2 is equals to 8 only. So I will check mid is here, whether 16 is affordable. Yes. So it is affordable. Let's mark mid as 16. Let's shift again. Start is equals to mid plus 1. So mid will come here to 20. Now, this mid will say, 20 will say, yes, I am affordable. So obviously range will cross. So 20 will be affordable at most by the 55 coins. So I will say how many 20 price chocolate can be, costlier chocolate can be bought. So I will say 55 by 20 is equals to 2 chocolates can be bought. Okay. So I will say, okay, answer is currently 2. And remaining chocolates will be remaining price from my coins will be 55 by 20, that is 15 coins. So I will say, okay, I'm remaining with only 15 coins now. Now we are done with this range. Okay. So obviously I will see that if I take this mid, okay, if I take this mid, now I have taken this 20 obviously. So obviously this 20 can be taken. Now we can say this 20 can no more be affordable by any coin, any chocolate. So I will say that I have 15 coins and this 20 coins will no more be affordable by me because of 15 coins. So I will say that my range will come here only. Okay. So when I do again binary search here, so I will say obviously this 10 is only affordable because 16 will not be affordable. Costlier 10 is only affordable. So I will say answer will be equal to 2 was already available. Now, because we can say 15 by 10 is equals to 1. So one more chocolate can be affordable and remaining will be what? 15 modulo 10. That means 5 coins are available now. Okay. Now tell me one thing, like when I've taken this 10, can this 10, 16, 20 will again be affordable? Obviously, I have taken these graders. These will no more be affordable. So obviously my range, my binary search range will come here. Now we will do binary search here. So I will say start to end here. Now I will say mid, let's come to mid here. Now mid will be at 3. Now 5 is obviously affordable. So I will try to find maximum cost here. So I will say that answer is equals to 5 by 5, which is equals to 1. So answer will be now 1. And remaining is equals to 5 modulo 5, which is equals to 0. That means I am remaining with the 0 coins. Okay. So in total, how many chocolate is affordable? 2 plus 1 plus 1. That means answer is equals to 4. So in this way, instead of linear search, we will apply binary search. But in optimized way, how? We will reduce the range. We will reduce the range again and again. This range and this range, because we don't need to again and again traverse the greater ranges because they are not required, obviously. Because if they are affordable, we have taken all, let's say 55 coins. So 55 coins were already affordable by 20. Now we have taken all the chocolates. Now we don't have to see it again. We will try to take smaller ones. Okay. So let's try to understand that how can we code up this approach. So what we do, let's take the start as 0 and end as n minus 1. Now, initially when we try to find the maximum possible affordable chocolate, so we will find, let's say 20. Okay. So this is end is obviously this, and start is equals to 0. Now what we will do, let's say my mid comes to 20. Okay. So the next time, what should be the end? End should be obviously this, because next range should come here. So that means whenever I find some element, I should come to end is equals to mid minus 1. That is the main. And every time, whatever value I've considered, I should add this to the answer. Okay, so I will say, let's have k coins. So I will say that answer plus is equal to k divided by price of mid, whatever is the price of the mid. And I will say that now number of coins that I'm left with, k is equals to k modulo price of mid, and that is whatever is the price. Let's say 50, 55 by 20 is equals to 2. So I bought 2 chocolates, and k modulo price, that is 55 modulo 20 is equals to 15. That means I am left with only 15 price. Okay. Now, next thing. Now I am telling that end is equals to mid minus 1. I have said that I have to optimize approach. Like, how can we do whenever I am here? So I have taken that many chocolates that I'm affordable with the given coins. So I will say that my next range should be here. So obviously start should remain as 0. Okay. But end should come beyond the mid. That means mid minus 1. Let's say I am came at 20 and I have taken this. This is a mid. Now this is affordable. So I will say next time what should be the end? End is equals to mid minus 1, obviously. Why? Because because obviously 10 will no more be affordable. That many chocolates that I can buy, I have taken already. Now I have to come to smaller range. Okay. Now we will again find mid here and we'll again draw. Now let's say I'm remaining with the 0 coins. Okay. So obviously end will what will be the mid here? Obviously mid will be beyond this 0 minus 1. So mid will become minus 1. Okay, so I will say that mid will become minus 1 because it will no more be affordable. So I will do the loop until my end is greater than is equals to 0. Whenever end crosses the range, so no more coins will be affordable. And within this loop, I will apply the binary search as we apply normally. From what? Start less than is equals to end. Why this end is greater than is equals to 0? So as to consider the given range, because let's say I've taken this range, let's have taken this range, let's have taken this range. Now whenever, let's say coins, let's say 2 3 4, and my coins left with 1, so obviously 2 3 4 can no more afford it, so it will come to minus 1 only index. So that means end will be not be greater than is equals to 0. So I will come out of the loop. So that is all about the approach. So let's code this approach. So first thing that I want to tell you, if I want to get the price of IS chocolate, so that we can get using the shop.get. This is the query that we have to make. And also they have said we can call this query at most 50 times. Okay. So that's why we are applying binary search. Why binary search? Because binary search, what will binary search do? If I apply the 50 operations, let's say 10 is per 5 array. So in the 10 is per 5 array, it will become 5 log 10 and it will become log to the base 10, 5 into 3.3. So at most 16 operation will take. Since you apply binary search here, here, here. So at most it can take 50 operations. Okay. So let's code up this approach. Now, first thing that we should make all these things public. Otherwise it will give error. Let's make all this public. Now initially what is the range? That is my range for full array. Start is equals to 0 and n is equals to n minus 1. Okay. Now what is the number of chocolate we are available with? Chocolate is equals to 0. Now what we will do? Until we do not cross the range, let's continue. Okay. Let's consider the current answer as minus 1 and let's consider current mid index, whatever we are getting, as minus 1. Okay. Now let's consider the 0 or we can apply minus 1, whatever we want. Okay. Now ln is equals to start is equals to 0. Okay. Now we will say that initially my start is equals to 0 and start is less than is equals to n as we apply normal binary search. What we do in normal binary search? We will take the mid as usual mid. Let's take this in long. Start plus n by 2, obviously. And then what we will do? We will find the current mid. We will make this query. Let's make this query. Give me the midth index price of the chocolate. Okay. So I will say whether this price is affordable. Yes. If it is affordable, let's mark the current answer as a val and let's mark the current index as a mid. That this price is affordable. Let's take this price. Okay. And if this is affordable, so obviously my target is to create higher range. So start is equals to mid plus 1. Else what we will do? End is equals to mid minus 1 as we do. Okay. Now, what is the last work that we have to do? Now, after that, what is the main task? Our main task is to add the chocolates. Okay. So I will add the number of chocolates, as I said, k divided by answer var. What is answer var? Answer var is the, let's say I was getting 20. I was getting 20. So I will say that this 20 we have got. So 55 by 20 is the number of chocolates that I can buy. And what is the number of, what is the price that I'm remaining with? K is equals to K modulo answer well. And what is the range that I have to refer? So my end should come to mid minus 1. And it should come to mid minus 1. Because this range I have to refer again. No need to check this range again. So I will say end is equals to mid minus 1. Okay. So now, obviously, end is equals to, because we are not storing, I think, mid. So we should make this answer of index minus 1, because whatever index I've got the answer, I will make that. Okay. Now, add then what I've written, number of chocolates. Now, I have created this LL. Let's create this macro hash define long int we can say. Okay. Now, let's compile it in the code. Mm, this let's compile it. So we should not make this answer value is equals to minus 1. If I make this answer value is equals to minus 1, so it will make k upon minus 1, it will make it minus k. If I'm not getting any answer from here, so it will make minus k and it will subtract the k from the chocolates. That will be wrong. So I will make the answer value as nothing. Okay, so let's again compile it in the code. Let's submit the code again. Yes, so it is totally working fine. So this question was a CodeForces type question, which is asked. So this was all about code. So please like and share to subscribe to my channel if you like the explanation. Thank you and have a nice day.